Hello, good morning everyone. Our topic for today is all about isenthalpic or throttling process. So kapag sinabi nating isenthalpic, it is a constant enthalpy process. Okay? So isenthalpic process is a process in which no work is being done and is utilized in getting the quality of steam. So sa isenthalpic process, meron tayong tatlong uh, diagram. So una is PV diagram. So let's say ang point 1 natin is mataas, then bumaba sa point 2. So ganito yung kanyang PV diagram. When it comes to TS, gano'n lang din naman, tumaas, mababa, then pataas. Then HS diagram, since constant enthalpy tayo, yung enthalpy natin ay constant lang. So from 1, tumaas yung entropy niya in 2. Okay? So, since sinabi ko nga kanina, no work is done, therefore, work non-flow is equals to 0. Kapag sinabi nating work steady flow, 0 din yan. Heat transferred is equals to 0 din. Change in enthalpy is equals to 0, but H2 is equals to H1 is equals to HF1 plus X1 HFG1. Okay, or mode 3. For approximate computation ng H2, it is equals to Hg plus Cp delta T, where the Cp of the steam is 2 kilojoules per kilogram Kelvin, and yung delta T natin is the degrees of superheat or degrees SH. So, ang formula natin ng degrees superheat is delta T is equals to T2 minus Tsat at P2. Okay. So, sample problem tayo. Number 1, steam at 1.4 megapascal at 270 degrees Celsius flows steadily through a steam throttle valve that reduces its pressure by 50%. Find the final temperature and the change in entropy. So, meron tayong given P1 of 1.4 megapascal, T1 of 270 degrees Celsius, and P2 of 1.4 times 0.5 kasi sabi, bumaba daw yung pressure niya ng 50%. So, i-multiply natin ng 0.5, therefore, P2 is 0.7. So, kalahati ng 1.4 is 0.7 megapascal. So, required natin is T2 and delta S. So, solution, at 1.4 megapascal, ang Tsat natin dyan is 195.07. Therefore, mas malaki yung given natin, no? 270 compared doon sa ating Tsat. T1 is greater than Tsat, therefore it is superheated. So kapag superheated, sa table 3 tayo titingin. Table 3, P1 is equals to 1.4 megapascal and T1 is equals to 270 degrees Celsius. So may eksakto yan sa table 3. So direct reading lang tayo, H1 is 2,973.3 kilojoules per kilogram and S1 is 6.8331 kilojoules per kilogram. Okay, so since constant enthalpy tayo, H1 is equals to H2, it is equals also to 2,973.3 kilojoules per kilogram. Okay, at P2 is equals to 0.7 megapascal. Kunin natin yung kanyang HF and HG. So, ang HF natin is 697.22. Ang HG natin is 2763.5 kilojoules per kilogram. So, compare natin siya sa H2, which is 2973.3. Ito, compared natin dito sa dalawa. So, H2 is greater than HF and HG, therefore superheated din yung ating condition 2. So, kapag superheated, doon tayo sa table 3 ulit titingin. Sa table 3, P2 is equals to 0.70 megapascal and H2 is equals to 2,973.3 kilojoules per kilogram. Okay, so may eksakto yung 0.70 megapascal. Titingnan mo na lang yung properties at enthalpy. So, yung pinakamalapit or napapagitnaan yung 2973.3 ay 2953.6 and 2974.9. So it is in between 250 degrees Celsius and 260 degrees Celsius. So yung S natin at 250 degrees Celsius is 7.1053. Yung S natin at 260 degrees Celsius is 7.145. Okay, so by mode 3-2, kunin natin yung T2 and S2. 250, then 260. Lagay lang natin yung enthalpy na 2973.3. Therefore, T2 is equals to 259.24 or 249 degrees Celsius. So, kunin natin si S2. Edit lang natin si Y, 7.1053 and 7.1455. Therefore, S2 is 7.1425 kilojoules per kilogram Kelvin. So, kapag okay na si S2 and T2, solve na natin yung required sa problem. So, unang required is T2. Yan, nakuha natin 259.249 degrees Celsius. So, delta S is S2 minus S1. So, 7.142 minus 6.8331. Therefore, delta S is 0.3089 kilojoules per kilogram Kelvin. So, that's it for our first problem. Doon na tayo sa second problem. A throttling calorimeter receives steam from a boiler drum at 0.11 megapascal and is superheated by 10 degrees. If the boiler drum pressure is 1.55 megapascal, what is the quality of steam generated by the boiler? Okay, so meron tayong P1 of 1.55 megapascal, P2 of 0.11 megapascal. So yung Tsat daw natin at P2, so kinuha natin yan sa table 1 at 0.11 megapascal. Ang Tsat natin dyan ay 102.31. Then meron tayong given na degree superheat of 10 degrees. So ang hinahanap is the quality or X1. Quality generated by the boiler or X1 yan. Okay? So, solution. So, ang formula natin, H2 is equals to H1 is equals to HF1 plus X1 HFG1. So, kunin natin muna yung properties at 1.55 megapascal. So, sa table 2 yan, So, at 1.55 megapascal, sa table 2, HF is 851.92 kilojoules per kilogram. HFG is 1,941.2 kilojoules per kilogram. And HG1 is 2,793.1 kilojoules per kilogram. Okay, so, para masolve natin si delta T, kailangan natin si T2 minus Tsat at T2. So, meron tayong degree superheat. Ang degree superheat is equals to delta T. So, T2 wala tayo. Tsat at P2, yun yung kinuha natin kanina, which is 102.31. So, ang masasolve pala natin dito is si T2. Therefore, T2 is delta T plus Tsat at P2. Okay, so substitute na natin. T2 is equals to degree superheat plus Tsat at P2, 10 degrees Celsius plus 102.31. Therefore, T2 is 112.31 degrees Celsius. Then, yung T2 na to, gamitin natin kasama yung P2 natin, which is 0.11 megapascal. Okay? So, at P2 and T2, 0.11 megapascal and T2 is 112.31 degrees Celsius. So, At ano to, no? At table 2 kasi saturated naman yung ating ano eh, ating hindi, ano pala to, sa table 3 kasi nag-superheat nga pala siya, no? So, since yung T2 natin is nag-superheat na, naging 112 kasi ang ating Tsat is 102, therefore, table 3 tayo titingin. So, at table 3, may eksaktong 0.11 megapascal pero wala tayong eksaktong temperature. So, napapagitnaan siya ng 110 and 120. So, ang enthalpy at 110 is 2695.3 and ang enthalpy natin at 120 is 2715.6. So, gamitin natin ito. Therefore, H2 is equals to H1. So, i-mode 3 to natin. 110 tsaka 120 2695.3 2715.6. So 112.31. Therefore, H2 is 2699.989 kilojoules per kilogram. So since okay na si ating H2 and si ating properties at 1 dito, i-substitute na natin siya dito. Okay? So H1 is equals to HF1 plus X1. Wait lang. Ayusin lang natin. HF1 plus X1 HFG1. Okay. So, si H1 natin, nakuha natin na yan, no? 2699.989. Si HF1, yung sa properties natin at 1, 851.92. Then, si X1, yan yung hinahanap sa problem. HFG1, nakuha din natin yan sa table 1 at properties 1. Table 2 at properties 1. Okay. So, input lang natin sa calculator. Mode 1. 2699.989 is equals to 851.92 plus alpha x 1941.2. So, shift solve. Ang sagot natin yan is 0.952 or 95.202%. So, pwede rin siyang isolve by mode 3-2. Lagay lang natin, quality at F is 0, quality of G is 1. HF is 851.92 and HG is 2793.1. Press AC, shift 155. Shift 154. Kasi ang hinanap natin is quality. Nilagay natin yung enthalpy na 2699.989. Therefore, enthalpy is 95.203%. Yan. Okay, so yan na yung sagot natin sa problem number 2. Then last problem. Last problem, a steam calorimeter receives steam from a pipe at 0.1 megapascal and 20 degrees Celsius. Superheated. For a pipe steam pressure of 2 megapascal, what is the quality of steam? So meron tayong given, P1 is 2 megapascal, P2 is 0.1 megapascal, and degree superheat of 20 degrees Celsius. So ang hinahanap ulit is the quality or the X. So, solution. So, by using approximate computation, ang formula natin ng H2 is Hg2 plus Cp delta T. So at 0.1 megapascal, kunin natin si Hg. So Hg2 is 2675.5 kilojoules per kilogram. At 2 megapascal, kunin natin si Hf1 and Hg1. We have 908.79 kilojoules per kilogram and 2799.5 kilojoules per kilogram. Okay, so solve natin si H2. So H2 is G2 plus Cp delta T. So H2 is 2675.5. Yan yung ating nakuha ang Hg2. Yung Cp ng steam is 2 kilojoules per kilogram Kelvin. Then delta T is 20 degrees Celsius or 20 Kelvin. So matitirang units na lang dyan is kilojoules per kilogram. So therefore H2 is 2715.5 kilojoules per kilogram. Okay, so solving for quality, gamitin natin si mode 32. Kapag F, ang quality natin is 0. Kapag G, ang quality natin is 1. So, ang HF natin is 908.79. HG natin is 2799.5 kilojoules per kilogram. So, mode 32. So, 0, 1, 908.79 and 2799.5. So, solving for quality, kunin natin si X hat, lagay natin si H2, which is 2715.5. Therefore, quality is 95.557%. Okay, so that's all for this topic, Isenthalpic or throttling process. So, kung may question, paki-message na lang ako sa Messenger. So, that's all. Thank you and keep safe.